Hankel transform of derivatives. Hankel transform of d square f by dx square plus 1 by x df by dx minus n square by x square f of x, where p is the root of the equation Jn of pa equal to 0. So we know that from the definition of Hankel transformation, Hn of f of x, which is equal to integral 0 to a f of x into Jn of px dx. Therefore, Hn of d square f by dx square plus 1 by x df by dx minus n square by x square f of x is equal to integral 0 to a d square f by dx square plus 1 by x df by dx minus n square by x square f of x into Jn of px dx. Just we are replacing f of x in the definition by d square f by dx square plus 1 by x df by dx minus n square by x square f of x, right? That is equal to integral 0 to a. We are splitting into three integrals. So first one, d square f by dx square x into Jn of px dx plus integral 0 to a 1 by x df by dx x into Jn of px dx minus integral 0 to a n square by x square f of x into Jn of px dx. So Hn of d square f by dx square plus 1 by x df by dx minus n square by x square f of x equal to integral 0 to a d square f by dx square x Jn of px dx plus integral 0 to a x and x in the numerator and x in the denominator, 1 by x into x, so both are cancelled. So remaining df by dx Jn of px dx minus, here you are having x in the numerator and x square in the denominator, so 1 x will get cancelled. So n square is constant, take it outside from the integration, minus n square integral 0 to a 1 by x f of x into Jn of px dx. That is equation number 1. Now integral 0 to a d square f by dx square x into Jn of px dx, which is equal to integral 0 to a d square f by dx square can be splitted into d by dx into df by dx into x into Jn of px dx. That is equal to integral 0 to a x Jn of px into, so derivative of df by dx. You can cancel like we are cancelling dx in the denominator, dx in the numerator. Just we are take it as it is. So that is equal to, so we are using u dv formula, right? U dv, uv minus integral v du. Here u is x Jn of px and v is df by dx. So uv, so x into Jn of px df by dx limit 0 to a minus integral 0 to a v df by dx du, derivative of x Jn of px, right? So that is equal to applying upper limit and lower limit, replacing x by a, upper limit a into Jn of pa df of a by da minus, when applying lower limit, that is x is equal to 0, so 0, right? Minus integral 0 to a df by dx. So we are using duv formula. So duv is equal to u dv plus v du, right? Here u is x, v is Jn of px. So u dv x into derivative of Jn of px, Jn dash of px, derivation of px is nothing but p, plus Jn of px, then derivative of x is 1, so into dx, right? So dx is common for the both terms. So next, which is equal to 0 because Jn of pa, right, it is equal to 0, so total term become 0 minus integral 0 to a df by dx x into Jn dash of px into p plus Jn of px dx, right? That is equal to minus integral 0 to a df by dx x Jn dash of px into p plus Jn of px dx. That is integral 0 to a d square f by dx square x into Jn of px dx, which is equal to minus integral 0 to a df by dx px Jn dash of px dx minus integral 0 to a df by dx Jn of px dx. We are splitting into two integral, right? That is equation number 2. Now using 2 in 1, hn of d square f by dx square plus 1 by x df by dx minus n square by x square f of x is equal to minus integral 0 to a df by dx px jn dash of px dx minus integral 0 to a jn of px dx plus integral 0 to a df by dx jn of px dx minus n square integral 0 to a 1 by x f of x jn of px dx. Here the second term and third term get cancelled because this is minus second term minus integral 0 to a df by dx jn of px dx. Then next term third term plus integral 0 to a df by dx jn of px dx. So get cancelled, remaining you are having minus p integral 0 to a df by dx x jn dash of px dx. P is constant, take it outside from the integration, right? Minus n square, last term minus n square integral 0 to a 1 by x, right, f of x jn of px dx. That is equation number 3. Now integral 0 to a df by dx x jn dash of px dx, which is equal to integral 0 to a x, we can cancel dx in numerator and dx in the denominator. So remaining you are having x jn dash of px into df. Again we are going to use u dv formula, integral u dv uv minus integral v du. Here u is nothing but x jn dash of px, v is nothing but f, that is f of x. So uv x jn dash of px into f of x, lower limit 0, upper limit a, minus integral v du f of x into derivative of x jn dash of px, right? That is equal to, when applying the upper limit, a into jn dash of pa f of a minus 0, right? Applying lower limit you will get 0, minus integral 0 to a f of x into derivative of x jn dash of px, which is equal to applying the this one. So remaining you are having a jn dash of pa f of a minus integral 0 to a f of x. So applying duv formula. So u dv plus v du. Here u is x, v is jn dash of px. So u dv. So keeping x and derivative of jn dash of px is jn double dash of px and derivative of px p plus jn dash of px and derivative of x, that is dx 1 into dx, that is dx, right? So integral 0 to a df by dx x into jn dash of px dx, which is equal to a jn dash of p of a jn dash of pa and f of a into f of a minus integral 0 to a f of x px jn double dash of px plus jn dash of px dx. That is equation number 4. Using 4 in 3, therefore hn d square f by dx square plus 1 by x df by dx minus n square by x square f of x equal to minus p into a jn dash of pa f of a minus integral 0 to a f of x px jn double dash of px plus jn dash of px dx minus n square integral 0 to a 1 by x f of x jn of px dx. Therefore that is equal to minus pa jn dash of pa f of a plus p integral 0 to a f of x px jn double dash of px plus jn dash of px dx minus n squared integral 0 to a 1 by x f of x jn of px dx, right? That is equation number 5. We know jn of x is the solution of Bessel differential equation, that is x square d square y by dx square plus x dy by dx plus x square minus n square into y equal to 0, replacing y by jn of x because jn of x is the solution, right? So x square d square jn of x by dx square plus x into d of jn of x by dx plus x square minus n square jn of x is equal to 0, replacing x by px, right, in above. So p square x square, so we will get dx is nothing but p dx, dx square is nothing but p square into dx square. So x square p square d square jn of px by p square dx square plus px d of jn of px by p dx plus p square x square minus n square jn of px equal to 0. That implies x square d square jn of px by dx square, p square in numerator and p square in denominator get cancelled. Second term also you are having p in the numerator and p in the denominator get cancelled. So you will remaining you are having x d of jn of bx by dx plus p square x square minus n square jn of px equal to 0. Therefore, this implies x square p square jn double dash of px plus, because the d square jn of px, jn of px 2 times derivative, right? So you will get jn of px, derivative of jn of px is jn dash of px into p, right? Again we are doing the differentiation, so you will get jn double dash of px into p, that is p square. So x square p square jn double dash of px plus similarly px into jn dash of px, right? Derivative of jn of px plus p square x square minus n square jn of px, right? This is the region, right? D by dx of jn of px and d square jn of px by dx square values, right? This implies x square p square jn double dash of px plus xp jn dash of px minus n square, taking minus outside, minus n square minus p square x square jn of px. Therefore, this is equal to x square p square jn double dash of px plus xp jn dash of px minus, we are taking p square x square outside from that, so minus p square x square, so n square by p square x square minus 1 into jn of px. This implies xp jn double dash of px, right? So xp is common in all the terms, right? All the three terms, right? So xp get cancelled because equal to 0, right? That equation is equal to 0. Therefore xp get cancelled in each terms. So remaining you are having xp into jn double dash of px plus xp cancel jn dash of px plus here also xp cancel, remaining you are having minus px x n square by p square x square minus 1 into jn of px equal to 0. That is xp jn double dash of px plus jn dash of px, which is equal to the negative term, we are taking it to the right hand side, right? So it will become positive, which is equal to px n square by p square x square minus 1 into jn of px. That is equation number 6. So now using 6 in 5, hn of d square f by dx square plus 1 by x df by dx minus n square by x square of x equal to minus pa jn dash of pa f of a plus p into integral 0 to a f of x p of x px into n square by p square x square minus 1 into jn of px dx minus n square integral 0 to a 1 by x f of x jn of px dx, that is equal to minus pa jn dash of pa f of a plus p into integral 0 to a f of x px n square by p square x square. We are splitting into two integrals, right? N square by p square x square into jn of px dx minus p into integral 0 to a f of x px jn of px dx. Then last term minus n square integral 0 to a 1 by x f of x jn of px dx, that is equal to minus pa jn dash of pa f of a plus integral 0 to a f of x p into p square, right? You are having px inside and p which is outside the integral, right? So p into p square x n square by p square x square jn of px dx minus same manner you are having minus integral 0 to a f of x p square x jn of px dx minus n square integral 0 to a 1 by x f of x jn of px dx, that is equal to minus pa jn dash of pa f of a plus n square, right, f of x into, because p square x in the numerator, p square x square in the denominator, so remaining you are having 1 by x, so f of x 1 by x into jn of px dx minus, here you are taking p square outside, so integral 0 to a f of x x into jn of px dx minus n square integral 0 to a 1 by x f of x jn of px. So that is equal to, see the second term n square integral 0 to a f of x 1 by x jn of px dx. Then last term, fourth term, minus n square integral 0 to a 1 by x f of x jn of px. Both get cancelled. So remaining minus pa jn dash of pa f of a minus p square integral 0 to a f of x x jn of px dx. Therefore, hn of d square f by dx square plus 1 by x df by dx minus n square by x square f of x is equal to minus pa jn dash of pa f of a minus p square hn of f of x. Because integral 0 to a f of x x into jn of px dx is nothing but Hankel transformation of f of x, because jn you are having, that is why hn of f of x, right? So deduction will be the next video, right? Thanks.